shaded region, y equals square root of x, y equals 0, and x equals 4. We're going to rotate this about the line x equals 4. And do you notice your shaded region is flush up? It's flush up against your axis of rotation. Okay? And that makes me suspect it's a disk. Okay? And let's take a look at this disk. Okay. Actually, let's say I don't know if it's a disk or not. I'm trying to decide. So this is kind of the generic formula. It might be a dx formula or it might be a dy formula. Okay. I'm rotating about a vertical line. Okay. So that actually tells me if it's a dx or dy. So which one is it? Dx or dy? Dy. If you're rotating about a vertical line, it is a dy problem. But let's say I'm not so good at memorizing that. All you do is you do that thing where you go from the axis of rotation to find your big R. From the axis of rotation through the region to the furthest point on the region, and that's your big R. And remember, your R is like your Riemann sum bar. So if you imagine this as a Riemann sum bar, do you see that it has a dy width? And that makes it also a dy. Okay, so two ways to figure out if it's a dy or dx problem. And there's my big R, so let me go to find big R. Okay, once you figure out the whole thing about from the axis of rotation through the region, forget it, okay? You already have your big R. You used it just to find your big R. Pull that out and decide, is that y minus y or x minus x? It's x minus x. So what you need to do is solve for x on the left side. That's pretty easy. That's x equals 4, okay? Solve for x. Can you get Major's lunch down there? Oh, no, it's not Major.
Right, yeah.
Because of the digits that come through. Okay. Where's Major's lunch? I'm going to put it outside the door. All right. So this big R is going to be x minus x. The x on this side, okay, remember this is y equals square root of x. So I need to solve for x here. Well, if I have y equals square root of x, to solve for x, you just square both sides, right? So therefore, x is y squared. So what I have is 4 minus y squared. Okay, that's the length of my R, my big R. And then I find my little r, or what is little r? Little r is from the axis of rotation. Don't go through the region and go to the closest point on the region. And do you see when I'm here at the axis of rotation and I don't go through the region, there's no point where I don't go through the region. Does that make sense? So therefore, there's no little r. So in another sense, the axis of rotation is flush up against my region. And so therefore, there is no little r. Little r is just 0. And so really, it was just a disk problem. And my y limits are here. Well, actually, let me write my problem. So we pi r squared dy, and I need my y limit. So go look at my region. What's the smallest y value on my shaded region? Guys, when you get your limits here, please don't consider the axis of rotation. That has nothing to do with these limits here. These limits here are only just your shaded region, and that's why it's so important to shade your region correctly the first time. And the shaded region is defined only by these equations, all right? So what's my lowest y point on my shaded region? 0. I lost my cursor. And what's my highest y point on my shaded region? 2, because if you plug in 4 here, you're going to get 2. So it should be 0 to 2. Okay. So this will be, there it is, 0, 0 to 2. Okay. Do you need me to go on, Charles, or you're good? You're good. Okay. What other number do you need help with on your homework? 11D. Okay, so let's look at, that's just right here. Okay, so let's look at 11D. We're going to do the same picture, but now we're going to rotate about x equals 6. There's your x equals 6. That's not 11D?
Just put it on the
Okay, so then we're going to rotate about x equals 6. So I'm going to say x equals 6 here. And do you see there's a space here now, right, between the axis of rotation and the shaded region? Let's just write our formulas. So our formulas of volume is pi r squared minus r squared. Dx or dy, can anybody tell me? Are we rotating by a vertical line or a horizontal? It's dy because it's a vertical line. But if you didn't know, you would say, okay, let's just draw my Riemann sum bar. from the axis of rotation, go through the region to the furthest point on the graph. That's my big R. So big R is equal to, and let me pull it out. Okay, pull it out. Is it y minus y or x minus x? X minus x. So I need an x equals on this side. I need an x equals on this side. So this will be x equals 6 on the right side. And we determined this was, oops, sorry, that's not right. This was it x equals y squared? Or, no, y equals, x equals y squared. Let me make sure that's right. It was y equals square root of x, right? And I want to square both sides there. So x is equal to y squared on this side. So this is going to be 6 minus y squared. Let me get my little r now. Your little r is, again, from the axis of rotation. Don't go through the region. Go towards the region, okay, to the closest point on the graph, on the region. And that's my little r. And no matter where I draw my little r, I don't know if you guys see it, it actually seems like it's the same length every time. That's kind of interesting. But what it is, it's going to be, if I get the length of this little r, let me pull it out of the board. If I get the length of this little r, do you see that it's an x minus x problem? Okay, so that's just 6 minus 4. Is everybody good with that? So 6 minus 4, which is just 2, and that makes sense that it's just a constant. All right, then I'm going to plug this into my equation. So when I plug this into my equation, I get volume equals pi 6 minus y quantity, 6 minus y squared, quantity squared minus 4 dy. This is a dy problem, so go up to your picture. Only look at the shaded region to get your limits. What is my smallest y value? What is my largest y value? 2. Okay, do you guys need me to put that in the calculator, or are you guys good from there? You're good from there? Okay. What other numbers do you need help with? 21. Okay, so here's 21. This is a picture of 21. It's a y scared picture, so look left and right. Why are you scared? It's a parabola. They're both positive. The x and y's are positive, so it's a right parabola. And x equals 4 is right here. We want to spin this thing about x equals 6. Okay? So if I say this is a volume, here's the generic formula for volume. Is it a dx or a dy problem? Am I spinning about a horizontal line or a vertical line? A vertical line. So is everybody okay with the dy problem? If you're not sure if it's a dy problem or not, go from the axis of rotation, go through the region to the furthest point on the region, and that's my r. And you can see that my r is like a Riemann sum bar, which has a dy width. Okay, so again, a second way you can verify that it's a dy problem. All right, the definition of big R, let me put it up here, is going to be, let me pull it out of the board. Is it a y minus y or x minus x length? X minus x. So that means I need an x equals on this side, and that's x equals 6, right? And I need an x equals on this left side, and it just so happens this is an x form. So this left side is x equals y squared. Is everybody good with the big R? Let's do the little r. The little r is from the axis of rotation. Don't go through the region. Go towards the region, but don't go through it to the closest point on the graph, and there's your little r. And the little r here is going to be 6 minus 4. Is everybody good with that? Really just right minus left. But it's going to be constant all the way through. All right, so this is 2. So this answer is going to be v equals pi, quantity 6 minus y squared minus 4 dy. All right, this is a dy problem. Okay, so I go look at my picture, make sure I'm pulling my y values, okay? For the shaded region, ignore the axis of rotation. What is my lowest y value and what is my highest y value? So what's your lowest y value here? It looks like -2. Do I need to verify it? It is -2. And what is my highest y value? 2. Okay, and that should give you the right answer. Did I square properly? No, I did not. I forgot this square. Thank you. Okay, and that should give you the right answer. Okay. Do you need me to put it in the calculator? That's good from here? when you put it in the calculator, you can just put all x's, okay? You can put y's too. Your calculator will get it right too if you put all y's, okay? What other questions do you guys have? Are you guys comfortable with discs and washers? Yeah? Okay, let's go on to today. So there's one example I want to do with you. It was an AP problem, and your homework is really just mostly AP problems. Okay? This thing keeps turning off, which is not a good thing. Okay, so let's look at some AP problems together. Okay, I want to look at this problem right here together. Find the area between 3 minus x squared and sine x from x equals pi over 2 to x equals 3 pi over 2. Okay? When you get a problem like this, the hardest thing to do, so I'm going to cover the graph, the hardest thing to do is figure out what the graph is. Okay? This is actually a calculator problem, but I can kind of see what this is. Right here, I can see this is a y equals x squared problem, which is a negative. Do you see it's a y x squared, but it's just a sad face parabola. Okay, and I kind of know what sine x looks like, right? Sine x looks something like this. Okay, so it's going to look something like this. This is a really ugly picture. Let me go to my calculator, and let me put this in my calculator and see what I have going on. So second, I just had a, okay, here it is, 7, 1, 2. Okay, let's go to y1. I'm going to define y1 as 3x minus x squared. I want to make sure that we're comfortable using the calculator, and we can use the advantages of having a calculator. Okay, if I stow this as y1 and y2 I stow as sine x, or I define it as sine x and y2, and I graph this, okay, I can see the picture of what this looks like. And really, I just want between pi over 2 and 3 pi over 2. Do you guys know the secret to change these things to pi? What's the secret? Zoom, trig. Go to zoom and hit number 7. Okay, what that's going to do is it's going to change your x tick marks to pi over 2s, which is pretty cool. Pi over 2s or pi's or something like that, okay? And so what happens here is you know what sine looks like. There's your sine function, right? So that means this must be 2 pi, this must be pi, do you guys see that? This must be pi over 2, and this must be 3 pi over 2, okay? So I've copied that picture here into my slides. Oops. Okay, and so I'm going to go ahead and graph my intervals here, okay? What I know is if I tick this to z trig, that this, okay, be careful though, the intersection of these two graphs is actually up here. It's actually not right at the x-axis. But at the x-axis, that's where my pi is, and that's where my 2 pi is, okay? But the intersection between these two graphs actually sits up a little bit higher. And my pi over 2 is here, which means my 3 pi over 2 must have been right here. So if I go find the area between all of this, it's kind of funky, but the area between these 4 equations is this part here and this part here. Okay, so that's the area I want to find. All right, and I want to talk about area right now, okay, because we get area confused with volume. So you've really only done 2 things in this unit, found area or found volume. When you have area, there really are only 2 formulas, okay? I know it seemed like a lot, but there were only 2. It was area equals top minus bottom, or it was area equal to right minus left dy. It was one of the 2 things, okay? So guys, when you're finding an area, write these and then pick one. Pick which one it is. Don't make it super complicated. When we were doing volume, okay, when we did cross-sectional areas, we said that we had volume equals integral of a dx, and we had volume equals the integral of a dy. Don't make it super complicated. It was one or the other, okay? Depending on what the cross-section was perpendicular to. When the cross-section was perpendicular to the x-axis, it's a dx problem. When the cross-section was perpendicular to the y-axis, it was a dy problem. And that's pretty much as complicated as it got, okay? And then we talked about rotating this, this region. But guys, when you rotated the region, what happened was when you took a cross section, the cross section was really just a circle. Okay, so this A right here, all it does is it represents the area of your cross section. If the area of your cross section is a circle, then it just turns out it's the same formula, but the formula turns out to be r squared, right? Pi r squared, because a circle has an area of pi r squared. If your area was a square, then this area formula is s squared. Remember, if your area was a triangle, it was s squared square root of 3 over 4. Okay, just whatever your cross-sectional area was, it came into here. And when we rotated things, it just turned out that our formula was pi r squared. Okay, and then we talked about if we had discs and washers, if you have a space, then this turns to pi r squared minus r squared. Okay, and this turns to pi r squared minus r squared dy. But really, these are all your formulas. Not very many, right? Okay, so if you can just memorize these formulas, it's really just a plug-in problem. And so since this is an area question, all we have to decide is, do we have a dx or a dy problem? On the volume side, you don't get to decide if it's dx or dy. If it's perpendicular to x-axis, it's a dx. If it's perpendicular to the y-axis, it's a dy. If you are rotating about a horizontal line, it's a dx. If you're rotating about a vertical line, it's a dy. You can't choose. But on the area one, you can choose. So let's look at this problem. Do you want to do a dx problem or do you want to do a dy problem? Which one? Yeah, dx is going to be easier on this, okay? And what that means is we're going to draw like dx problems, like the width of these things, these Riemann sum bars are going to be dx. But do you notice the area of that is going to be different, or the height of that will be different from the height of these Riemann sum bars here? So I'm going to do a red and a blue, and I'm going to add them together. You guys said this is a dx problem, so I'm going to keep it dx. All right. On the red side, okay, the area is going to be, again, top minus bottom dx. So if I did top minus bottom, really what it's saying is y minus y. If you pull this red Riemann sum out, okay, what's the top y function and what's the bottom y function? I can't even tell. The top one was this one, right? Okay, so let me call this one y1 equals 3x minus x squared. And the bottom one, I'll call this one, is y2 equals sine x. All right, so this is going to be 3x minus x squared minus sine x dx. But do you agree that, oops, let me get the integral in. But do you agree that that's really just the same as y1 minus y2 if I put it in my calculator, dx? And what are my x's going to go from? What's my smallest x on this red region? What's my smallest x? Do you see it's pi over 2? What's my right xmost region, though, point, though? It's an intersection, so you have to go find that. Let me just call that A. I don't know what that is yet. Let me call it A. Do you want to call it a different letter since this is already area, or is it okay calling it A? Okay, we'll call it A. There's a lot of Asians in here. It'll be fair. Okay, so then right here, someday I'm going to get in so much trouble. Okay, right here, I want the same thing, the area equals top minus bottom dx, but I'm going to do it for the blue side. Okay, on the blue side, do you see that the area is actually equal to, my top has switched. Do you guys see that? So now the top function is what? Sine x minus, now be careful, minus the quantity, 3x minus x squared. Is it x squared or x cubed? X squared. Okay, so if you actually punch this into the calculator, you need to definitely put parentheses or definitely make sure you distribute your negatives. But guys, if I punch this into my calculator, do you guys see that this would really be just the integral of y2 minus y1? You guys see that? Because I've already stowed y1 and y2 in my calculator, right? Anyways, right? And if I haven't, I'm going to need to put it in anyway to find my intersecting points. Okay? So you could just call it y2 and y1. And what would be, this thing just turned off again. What would be the bottom point here? A. And what would be the top? 3 pi over 2. Okay? So let me go to my calculator. Okay, and just really put all of this in, but I still need, let me find A first. Okay, I've already got my y1 and y2 put in. You guys see it's already in. Okay, let me find my A. So I go to my graph. And what I want to do is find the intersecting point right here. Okay, go to second Calc 5. Okay, go to the left side of that intersection, hit enter. Go to the right side of that intersection, hit enter. And the closer you are to the intersection, the less work your calculator has to do. But honestly, your calculator can work pretty fast. Okay, so the intersecting point is 2.927. Can someone do a check on that for me? Okay, do you guys see which one I need, my x or my y value? X. So I'm going to ignore the y value because I'm not going to need it. So I'm going to call that x A. So I'm going to go to second quit, put in your x because that's what your calculator knows has stowed for a 2.9 number. Hit stow, hit alpha A. Okay, and the reason I do this is so that I can pull up the A again anytime I want. All right, now let's do a math 9. Okay, and put these numbers in. I'm going to copy basically this expression just like I have it. I'm just going to do one at a time though. So let's just do the left expression. The bottom limit is going to be second. It's going to be pi over 2, so I'm going to hit second pi divided by 2. Okay, the top limit is going to be A because I've already stowed it as A. So you just hit alpha A. Okay, the integrand, do you see it would just be y1 minus y2? I mean, you could type it all out if you want, but you could also do vars, y vars, function, the first function, minus the second function, which is vars, y vars, function, and choose y2. I want the second function now, okay? And that'll be a dx problem. Pray, hit enter, and what I get here is this sum right here, or this integral right here, is 1.1058, and it goes on. All right, you're not supposed to round yet, although I'll bet you if you put out enough numbers, you'll be okay on this problem, okay? But you're not supposed to round yet. So on principle, I'm just going to stow this as alpha B. Did I do that right? Alpha B. Okay, and so this will be my B, and I can go back and add it to this number, okay? Let me go start all over, and I'm going to do this right side. Okay, I'm going to pull my thing down a little bit so you guys can see it. There's my answer. I'll leave it up just to check. On my right side, this will be math 9 again. And now it'll go from alpha A to 3 pi over 2. So 3 second pi. Oops, that's not second. 3 second pi. Oops. I'm terrible at the calculator. Okay, math 9. Alpha A, 3 second pi divided by 2. And the integrand is going to be now y2 minus y1. So I'll hit vars, y vars, 1, and start with a y2, subtract vars, y vars, 1 for function, and then subtract y1. The d will be a dx. And so then you pray, hit enter, and I get this number. I don't really need to stow this number. If you wanted to, you can. But I just want to add this number with my alpha B. Alpha B. Okay, and what I get is 6.193, and there's my answer right there. Okay, here's your picture right here. And the first picture they actually give you the picture. And they say one of these functions is a sine function, and the other is a cubic function. Can you tell by looking at the picture which is which? Yes, and you do have your calculator too, so you could confirm it. But this one right here looks a lot like the sine function, okay? So this right here is going to be y equals sine pi x. And on the bottom here, this is going to be y equals x cubed minus 4x. All right, I've got my two functions. The first question says find the area R. Okay, so find the area of R. Remember, guys, area only has two equations, two formulas. It's either going to be top minus bottom dx, or it's going to be right minus left dy, one or the other. So you just choose. Do you want a dx problem or do you want a dy problem? Dx. If you choose dy, you're going to be in big trouble for this problem. Okay, I have no idea how to do it. Okay, but you notice when you do dy's, all of your rectangles are actually going to have this, dx, all of your rectangles are all going to have the same formula. So let's figure out what this formula is. What's the top minus bottom here? Sine x minus this quantity, right? X cubed minus 4x dx. All right, let's figure out the limits of this thing. On the shaded region, what's your smallest x value? 0. What's your largest x value? 2. And that's pretty much it. You enter this into the calculator. This is a calculator problem, and you'll be okay. All right. If you are a little bit proactive, you might put this as y1, this is y2. Okay, you might define it like that. And that might help you a little bit in your calculator. Does anybody want to shout out your answer? We can check together, or we can just move on.
4.
4? Did anybody else get 4?
No.
Okay, so that's your answer, 4. Well, that's kind of strange. Okay, let's go to letter B. Letter B says there's a horizontal line, y equals -2, that splits the region into 2 parts. Write the integral expression, don't estimate it, don't evaluate it, just write it, for the area of the part R that is below this horizontal line. All right, so what I'm going to do is I'm going to add this line in. This line is y equals -2. Okay, and they want me to find the area underneath this line, basically. Okay, so let me highlight the area underneath this line. Can you do it? I think you can. Okay, remember this top function is y equals sine pi x, and the bottom function is y equals x cubed minus 4x. This is letter B. Let's go ahead and set this up. They want an area. So guys, there's only 2 formulas for area. Area equals top minus bottom dx, or area equals right minus left dy. Which one do you want to use for this problem? Top minus bottom or right minus left? Yeah, again, top minus bottom I think is the only thing that you can do. So let me put in some Riemann sums here, top minus bottom. It does look like the y minus y is all the same here. Okay, so I'm going to do a dx problem. And what is the top function going to be here? What's my y equals to on the top? -2. I'm going to subtract. What is my bottom function on the bottom here? Okay, so quantity x cubed minus 4x dx. Again, guys, make sure you put your parentheses in. If you don't put your parentheses in, make sure you distribute that negative. All right, this is a dx problem. So what are my limits for my x? Whoa. Yeah, this is where you need your brains or your calculator, okay? Let's go ahead and put in, you just set these 2 equations equal. Does that make sense to find the intersecting points? You want to find the intersections here. That means -2 is equal to x cubed minus 4x, okay? Whatever x are the answers here, those are going to be your x limits. When you do this, you should see that you want to have a conniption fit. Like you should feel a fit coming on. So basically, this is a calculator problem. It's going to be way easier to do in the calculator. So let me go to my calculator and define y1 now as -2, and define my y2 as -x cubed minus 4x. Oh, it's positive. Sorry. Good. Thank you. Okay, and I'm going to graph that. And I just want the intersecting points. I already have this on Z-trig, which is fine. It doesn't matter. I'm going to get this point here and this point here. Is everybody good with that? So go to your second calc, intersect. Okay, go to the left of your point, hit enter. Go to the right of the point you want. It'll only do 1 point at a time. So I'm going to do this left point first. And then hit enter. And then it says guess, I hit enter, I let my calculator calculate it. And can you guys confirm I got 0.539? Okay, so that's going to be my x value. I'm going to stow that as actually you just have to set it up, right? You don't have to evaluate it. So guys, what you need to go is make sure you do 3 decimal places, and the left one's going to be 0.539. Does that make sense? Because this is my answer, so I can round at this point. Okay, let's go to the right point here. So again, do a second calc 5. Okay, go to the left side of that point, hit enter. Go to the right side of that point, hit enter. When the calculator asks you to guess, hit enter again. Okay, and then that is actually my x value there. And so I'm going to recopy that into the top limit. and that's 1.675. Can I get a check on that? So 1.675, and if you just left it like that, that would be a great answer. Okay, let's look at letter C. Letter C says the region R is the base of a solid. Okay, so this is a base. It's a base. What do we know that has bases? Cross sections with no base. Okay. For this solid, each cross section perpendicular to the x-axis. You put in cross sections perpendicular to the x-axis as a square. Find the volume of this solid. So if you imagine what we're doing, we've got a foam board, right? This is the foam board. You guys good with that? That is a graph of the foam. It's the base, okay? We're going to put cross sections on it that are perpendicular to the x-axis. Here's the x-axis. We're doing perpendicular to the x-axis. Is this a dx problem or a dy problem? Dx, okay? We only have one formula for volume, guys, a dx. You guys good with that? So the volume formula is going to be a dx, and we need to be able to find the formula of a. Now, what shape is a? It's a square. Okay, so let me put these in. Okay, we're going to lie cross sections. These are like your pins. You're putting your pins in, and you're putting cross sections here. We said our formula for volume, there's only one formula. It's a dx or a dy. You told me this is a dx problem, so it must be a dx. This a represents the area of the cross section. You told me the cross section was a square. Okay, this square, if I pulled out one of these figures, it's a square. You guys good with that? Okay, so what is the length of one of these sides going to be? What is the length of this side going to be? Okay, let me pull it out. Maybe it'll help. If I pull it out, what's the length of this thing? You see it's y minus y. Okay, so this length is going to be sine pi x minus quantity x cubed minus 4x. Okay, if that's the length of the square, can I get the area of the square? Yeah, it's just that squared, right? So the answer is going to be, let me see if I have room here. Volume is equal to sine pi x minus quantity x cubed minus 4x. Take this whole thing, square it, dx, right? And if you're putting this in your calculator, you could just say this is y1 minus y2, right? Because that's how it's stored in your calculator right now. Maybe the hardest part, maybe not, is getting the limits. This is an x problem. If I go look at my shaded region, what's my smallest x value? What's my largest x value? How easy was that? Okay, are you guys feeling pretty smart? Okay, first 3 AP questions, you pretty much nailed them. All right, let's look at question D. Question D says the region R models the surface of a small pond. At all points in R, so in this region, which is like the lake in your neighborhood, at all points in this region at a distance x from the y-axis, so if you go a certain distance from the y-axis, the depth of the water, the depth right here, is given by 3 minus x. Okay, that's the depth, all right? And then if I went another, distance, the depth here, okay, the depth of this, at this linear line here would be a depth of 3 minus x. Okay, so if this x, let's say, if the x is 1, so right here x is 1, then the depth all along this line is going to be 3 minus 1, which is 2. So this has a depth of 2. So h equals 2. At 1/2, let's say, at 1/2, the depth all along this line here, the depth here, is going to be 3 minus 1/2, which is 2. So the depth here is 2. Okay, the depth here will be different. The depth here will be different, but they'll all be 3 minus x, whatever the x is. And so it turns out that all along the line, okay, the height or the depth, I mean, you could call it depth, but the height coming out of the paper or coming down from the paper maybe, okay, the depth of this pond, okay, it's all the same along any line here, all right, but each one's different from each other. And so you've got a whole bunch of different depths, okay. What kind of problem is this? Yeah, it's a
it's cross sections with a rectangular cross section, right? It's area of a cross section. Find the volume of an area of a volume of a with a known base, right? And with area of a cross section being a rectangle, okay? And so what you want to do is you want to pull one of these rectangles out, and the the length of this rectangle here, okay, would be equal to this darkened line here, and this length is a y minus y, okay, and the y up here is the sine function, right? This is y equals sine pi of x, and the y down here is the parabola. This is y equals x cubed minus 4x. So this distance right here is the top y minus the quantity bottom y, all right? And for each height, or we can call it depth here because it's actually going down instead of up, it's the same thing. You put a bunch of rectangles all along this known base, and this height is always what? It's always 3 minus x, okay? And we know the volume of cross-section areas with a rectangle on a known base. That formula, okay, is the integral of either a dx or it's the integral of a dy. It's one or the other, okay? And if we take a look at these lines we've drawn, the cross sections are perpendicular to the x-axis, okay? These are the cross sections. So therefore, it is a dx problem, not a dy problem. And all we'll do here is we know what A is. A is the area of the cross section. So what is the area of this cross section? The area of this cross section is sine pi x minus a quantity x cubed minus 4x times, or this whole thing, right? This whole thing times 3x dx. And this is a dx problem. So what is if I go look at my my base, the region on my base, what is the smallest x value? 0. And what's the largest x value? 2. And this is what I want to integrate to find the volume of water in this pond. An easier way to do this, if I'm looking at the calculator, is I can call this sine pi x y1 and call this x cubed minus 4x y2, and I can enter right into my calculator. So let me get my calculator out. And if I look at y equals, I already have sine pi x here and x cubed minus 4x here. So what I need to do is go to my home screen, second quit, do a math 9, okay, and then just copy what I have here. I want to go from 0 to 2, and I want to put in the integrand, but the integrand here is y1 minus y2. I mean, I can type out the sine pi x, but there's no reason to. It's represented by y1, so I can hit vars, y vars, function y1 minus, and then let's pull out the y2 function, vars, y vars, function y2, and I want to take that and multiply it by 3 minus x. So I actually need another parentheses here. So let me insert a parentheses, insert a parentheses here, and multiply this by 3 minus x. Okay, so I don't know how many parentheses I have here. Okay, and then I'm going to hit x. All right, pray, and this is where I get 8.369, and that is my volume of water in the pond. You can also call this 8.370.